Okay, so I think in a lower class you have learned about bonding, right? So
Yes.
what is bonding? Whatever you know in bonding, can you share so that it becomes easier for us?
Like in bonding, sir, like the definition.
Not just the
Chemical
definition,
bond.
what it means. Yeah. What are the types?
So chemical bond can be defined as an attractive force which can hold various constituents, that is atoms, ions of a different species altogether. That's a chemical bond. Then we have the types of bonds, which are single covalent bond, double covalent bond, triple covalent bond. Single covalent bond means the bonds which have where carbon is having a single bond present between the molecules, and double bond means where carbon has a double bond present, and triple bond is where triple bond is present between the carbon atoms of a given molecule.
What are the other kind of bonds which are there? You've spoken about covalent bond, right? Is there any other type of bond?
Electrovalent bond.
Electrovalent bond. So what is an electrovalent bond?
The bond formed as a result of electrostatic attraction between positive and negative ions is termed as electrovalent bond.
Okay, could you give me some examples? Example for a bond which is electrovalent. What are the other types of bonds? Go ahead. Okay, among electrovalent and covalent, which is stronger?
Covalent.
Hello? Okay, what is the definition of electrovalent bond?
The bond formed as a result of electrostatic attractions
That's fine.
between
Not
positive
just attraction, but talk about what happens with respect to electrons.
What's the sorry?
What happens with respect to electrons? Electrons play a major role in bonding. What happens? Okay. Have you heard about coordinate bond?
No, sir.
No? Okay, no problem. So just let's move on. Okay. So in a nutshell, I'll just give you some ideas first. Then we will get into the detailed explanation of all this. Okay. And bonding, as you know, is a very, very, very important chapter with respect to your 12th also. Right?
Yes, sir.
Sure. Okay. So let me just give you some fundamentals and then we'll go to the detailed explanation. Okay. So if you see, so you said electrovalent, right? Okay. So electrovalent bond is otherwise called as ionic bond. Okay. So what is an ionic bond? It is a bond formed, but due to complete transfer of electrons from one atom or species to another atom or species. Of course, next point is, you can say, it's formed because of the electrostatic force of attraction between the opposite charges. Okay, fine. Now, primarily you must talk in terms of electronic configuration. So if you see sodium, for example, the atomic number is 11, right? If you see the electron distribution, right? So let's say that the nucleus of the sodium atom. So what does the nucleus contain?
What's it?
What does the nucleus contain?
Protons and electrons.
Protons and electrons. Nucleus of an atom. Nucleus.
Neutrons. Neutrons.
Correct. So atomic number is 11, usually represented by Z. Atomic mass or mass number is 11. And mass number is 23 for sodium. What is mass number, Samuel? What is mass number?
The number of protons and neutrons associated with an atom.
Yeah, so it's a sum of number of protons. So you need to do a plus, right? Number of neutrons. Now that gives you this combination gives you the mass number, right? So for sodium it is 23, right? Which means how many neutrons are there?
12.
12 neutrons are there, yeah. 12 neutrons are there. 11 protons are there. That's the nucleus, correct?
Yes.
Then surrounding the nucleus you have orbits, right? These are paths which the electrons follow, right? So how many electrons are there? 11 electrons are there. So what is
Yes.
atomic number?
Atomic number is 11.
Yeah, what is the definition of atomic number? What is the atomic number of an atom?
Number of protons present in the atom.
So you can say it is the number of protons present in a neutral atom, or you can say number of electrons present in a neutral atom. A number of protons is equal to number of electrons in case of a neutral atom, right? Sodium is a neutral atom, correct?
Yes, sir.
So how many electrons are there?
Contains 11.
11 protons and 11 electrons, right? Protons are contained within the nucleus and electrons are going to revolve around the nucleus in specific paths called orbits. So let me represent the electrons with this symbol. So in the first orbit, you're going to have 2 electrons, which are going to be there. Second orbit, which is a larger orbit, it can accommodate a maximum of 8 electrons. How do you know what is the maximum number of electrons that can be accommodated in an orbit? Yes, Samuel? What is the maximum number of electrons that can be accommodated in an orbit? Yes. It is equal to 2n square. Okay. What is n? Nth orbit. For example, first orbit. N is equal to 1. So it is 2 into 1 square. So that is 2 into 1, 2. So the first orbit can only have 2 electrons. Can you estimate how many electrons can be there in total in the second orbit?
There can be 4.
Not 4, 2n square.
2 square.
N is equal to 2, right? N is equal to 2, you substitute. N square will become 4. 2 into
8.
4, 8. Yeah. The second orbit can accommodate 8 electrons, all right? So in the second orbit, there are 8 electrons. Right? Now, how many electrons have we taken care of? 10 electrons. Am I right?
Yes, sir.
In the second orbit, in the first orbit, 2 electrons. So how many more electrons are there with sodium?
There are 10 electrons. Okay.
So 10 electrons I have accommodated, but how many electrons are there in sodium? It is atomic number. So what is the atomic number of sodium?
11.
11. Therefore, that's equal to the number of electrons. So how many electrons are there in sodium?
11.
11 electrons are there. I have already accounted for how many electrons?
10. So we need one more.
One more electrons. But that cannot be accommodated in the second orbit. Do you agree?
Yes, sir. You know.
Yeah. So it goes to the third orbit. This we can call as the outermost orbit, right? So there is one electron in the outermost orbit. All right. Now, why do atoms combine? Right? So atoms combine in order to attain something called a stable electronic configuration, or in order to achieve stability. So as such, atoms with their original configuration are not stable. So what refers to stability is having 8 electrons in the outermost orbit. having 8 electrons in the outermost orbit corresponds to stability of an atom or an ion. So if you look at sodium right now, how many, which is the outermost orbit right now, Samuel? First, second, or the third?
The third one.
Third one, right? And how many electrons are there in the third orbit?
1.
1. However, what would you prefer to have?
Prefer to have 8.
8 electrons, isn't it? So that will correspond to stability. So as such, sodium atom is not stable.
Yes.
Right? It's not stable to the extent that we desire. All right.
Yes.
Okay. So it needs 8 electrons in its outermost orbit. So there are two options with us. One option is the third orbit, which is the outermost orbit. Right now it has 1 electron, right? We can add up 7 more electrons, isn't it?
Okay.
So if you add up 7 more electrons, how many electrons will be there in the outermost orbit now for sodium?
8.
8. And it will be stability, right?
Right.
Or we can do one more thing. The electron which is there in the third orbit, if there is a process by which it can be lost, it can be donated, it can be given to some other atom which is craving for electron.
Right.
Then what will happen is the second orbit becomes the outermost orbit. Because there is nothing in the third orbit now.
Yes.
Because you have given the electron which is there. So second orbit becomes the outermost orbit, and already the second orbit has how many electrons?
Yes.
Already the second orbit has how many electrons?
10.
Second orbit. This is the first orbit. This is the second orbit. This is the third orbit.
Now that is 8.
Yeah, 8. So second orbit has 8, correct?
Right.
Which corresponds to stability, isn't it?
Yes.
So which is easier, right? Adding another 7 electrons is easier, or removing another removing 1 electron might be easier.
Removing 1 electron.
Removing 1 electron is much easier. Easier when I say in terms of energy. So whatever we want to get accomplished, we have to do some work, right?
Yes, sir.
That requires energy. So if I have to dislodge an electron from the orbit, I have to give energy. If I have to add electrons into an orbit, again, I have to supply some energy. In some cases, there is something called as electron affinity, where the atom is very glad to take electrons, so that energy need not be supplied, but it will be released. Okay, that we will see later. But right now, you can understand that removing this electron is easier, right?
Yes, sir.
That's exactly what happens in a sodium atom. So sodium atom loses this electron which is in the third orbit, correct?
Yes,
so
sir.
how many electrons will be there now after this loss?
In the second orbit.
No, totally how many electrons will be there with sodium after losing this 1 electron?
10.
10. How many protons will be there?
10.
Not 10. Nobody is going into the nucleus and pulling out a proton, right?
Oh, right.
So proton, how many are there?
11.
Still 11, right? Proton has positive charge. Electron has
Negative charge.
So 11 positive charges are there. Neutron is neutral. So 11 positive charges, and how many negative charges?
10.
10. So 11 plus and 10 minus. So effectively, if you see, there is 1 plus.
Yes.
Understood?
Yes, sir.
That is why sodium, after losing an electron, becomes sodium plus. Is it clear to you?
Yes, sir. So if it gains an electron, then it will be sodium minus, right? Cl minus.
Correct. So now what is happening? Sodium is losing an electron. It becomes sodium plus, correct? For this to happen, right, for dislodging an electron from the outermost shell of an atom, you need to supply some energy, and that energy is called ionization energy. This will happen when you supply something called ionization energy 1. Why do you call it 1? You're removing the first electron. I know the outermost electron, right? So that energy is called ionization energy 1. Now, if you want to further remove another electron, it's called IE2. Okay. Is it clear, Samuel?
Yes, sir.
what do you expect the ionization energy of sodium to be? High, low in comparison with other atoms? It is low. Ionization energy for sodium is low. Why? Because it already has a tendency to give away that electron. So removing that electron is not a big deal. Okay. So what has happened in this process now? Sodium has become.
What was it?
Sodium, in this process, what has happened? Sodium neutral atom has become what? Sodium plus.
Right.
It has become a cation, right?
Yes.
Okay. Now, so somebody is giving the electron. There must be somebody to accept the electron, isn't it?
Yes.
Now let's talk about chlorine atom. Have you taken down whatever is needed?
Taken down, sir.
Yes. So now let's say I have chlorine atom. What is the atomic number of chlorine?
17.
17, right? And what is the mass number?
35.5.
35, right? Okay, right. Or 37, of course. It's an isotope.
Yes.
So now, so let's say this is the nucleus of sodium. I'm sorry, chlorine. How many inside the nucleus? What is present?
Protons.
How many protons are going to be there? What is the atomic number?
17.
What is the definition of atomic number?
Number of electrons is equal to number of protons.
Atomic number is either you can say it is equal to the number of protons or is equal to the number of electrons in a neutral atom, right?
Yes, sir.
So how many protons are going to be there?
17.
Yes. 17 protons are going to be there. How many neutrons are going to be there?
18.
18. Very good. There are going to be 18 neutrons, right? Okay. Now, because of the 17 protons, there is going to be 17 positive charges, correct?
Yes, sir.
All right. Now, so let's draw the first orbit of chlorine. How many electrons do you expect the first orbit to contain?
2.
2. Very good. And there can only be 2, right?
Yes,
Maximum of 2, not more than that, right? And what is the formula used to calculate the number of protons,
2n squared.
electrons in a shell?
2n squared.
Very good. Okay, now in the second orbit, how many electrons do you expect?
8.
Yes. Okay. Now, how
Yes.
many electrons have you accounted for?
10.
10. How many more are to be accommodated?
7.
7. And I can't have more than 8 electrons in the second orbit, right?
So you have to put one more orbit.
One more orbit, yes. So this is third orbit. And how many electrons?
7 electrons.
7 electrons we are going to accommodate, right?
But it's not stable.
Yes, very good. So it is not stable to the desired extent because there are 7 electrons in the outermost orbit. How many electrons in the outermost orbit corresponds to stability?
8.
8 electrons, right? So that hint we get it from rare gases or what we call as noble gases. If you look at noble gases configuration, right? Exception is helium. Helium alone has a duplet structure. How many electrons in its outermost orbit? 2. Then you have neon. What is the atomic number of neon? That is 10. So electronic configuration, if you see, 2 electrons in the first orbit. Second orbit, there are 8 electrons.
Right.
Next, let's say if you see argon. So if you observe, sodium and noble gases are highly stable. That's why they don't, react.
Right.
All right. They're already, kind of self-sufficient. They're stable. They don't want to, they're not in pressing need to combine with some other atom.
Yes.
All right. Argon, if you see the atomic number is 18.
288.
Yes. So now if you see, sodium after losing that 1 electron is attaining neon gas configuration. Hence it is stable. Okay, now chlorine, what is happening is now there are 7 electrons in its outermost orbit. You can do one of the 2 things, right? One is what? You have 7 electrons in the outermost orbit, right?
Yes.
You can supply enough energy so that all the 7 electrons are removed from chlorine.
Okay.
If you remove 7 electrons, then which becomes the outermost orbit? There's nothing in the third orbit, right?
So the second orbit.
Second orbit becomes outermost orbit, and how many electrons are there?
There are 8 electrons.
So it corresponds to stability, right?
Yes.
So if you remove 7 electrons from chlorine atom, then it will become stable.
Okay.
On the other hand, you can do one more thing. You could instead of taking out 7 electrons, you can just add one more electron. If you add another electron, the outermost orbit is still the third orbit, and how many electrons has it got now?
It will have 8.
It will have 8, and that will correspond to stability.
Stability.
And obviously, adding one more electron is much easier than
Removing 7
removing 7 electrons. Is that clear?
Yes.
So what chlorine has a tendency to accept an electron. Sodium had a tendency to what?
Lose the electron.
Lose an electron or give away an electron. Chlorine has a tendency to accept an electron. So what happens is when it accepts an electron, how many electrons are there now?
8.
8 in the outermost orbit. Totally, how many electrons are there with chlorine?
18.
18. How many protons are there?
17.
Yeah, 17 positive charges, 18 negative charges. So one excess negative charge is there, isn't it?
Yes.
That's the reason chlorine, after accepting an electron,
Cl minus.
yes, it becomes Cl minus. The amount of energy that is released in this process is called electron affinity.
It's called what?
So the amount of energy. So in case of sodium, for removing an electron, you have to supply energy. All right.
Right.
Because you are adding an electron to chlorine, it did not require supply of energy, but it followed with release of energy. Because chlorine has a tendency to accept the electron, right?
Yes.
And there are 17 protons which are waiting to attract that electron. Therefore, you don't have to supply extra energy to add an electron.
Right.
Because in sodium, as you mentioned earlier, so there is an electrostatic force of attraction. What is electrostatic force? Force existing between charges. So in sodium, if you see 11 protons, we are attracting the 11 electrons which were there.
Yes.
So you have to break that force of attraction, and then you have to remove that electron. All right.
Yes.
So it required energy. Here what's happening is your 17 protons are attracting 17 electrons. Now, when you're adding an electron, you're not opposing the electrostatic force of attraction, but rather you're working with the electrostatic force of attraction.
Yes.
Therefore, what happens is you don't have to supply energy for this to happen. So energy is indeed released in this process. Chlorine is more than happy to accept that electron. So this energy released is called electron affinity, measured in joules. So you call it as EA1. Is it clear?
Yes.
Okay. So now sodium is willing to give the electron, chlorine is willing to accept that electron. So there is a complete transfer of electron from sodium to chlorine.
Yes.
So this forms a bond, and this bond is called ionic bond or electrovalent bond. So what happens in an electrovalent or ionic bond? There is complete transfer of electron from one atom or the combining species to the other. So you can see sodium loses an electron, becomes sodium plus. Chlorine accepts that electron and becomes Cl minus.
Yes.
So that's how sodium plus chlorine combines to give you
NaCl.
Na plus Cl minus. So formation of ionic bond or covalent bond is favored by these factors. First one is one of the participating atoms must have low ionization energy. Usually metals have low ionization energy. What is ionization energy? Energy required to pull out that electron, correct?
Yes.
Yes. And the other atom should have high electron affinity. That means it must be ready to accept the electron, right?
Yes.
Usually non-metals have higher values of electron affinity. Example, if you see, in case of metals which have low ionization energy, sodium, high electron affinity, chlorine. And beyond that, if you see, the compounds which are forming ionic bonds or electrovalent bonds exist in crystal structure,
Right.
exist as a crystal lattice. Therefore, the lattice energy must be high. It is the amount of energy that is released in the formation of when the lattice or the crystal lattice is formed. The sodium chloride, if you see, they exist as a crystal. Ordered arrangements will be there. So there must be high lattice energy. That means sodium and chlorine, when they're combining and forming crystal, huge amount of energy needs to be released. Then ionic bond is favored, which
Yes.
means two things. Number one, lower the energy, more the stability.
Okay.
Anything that has high energy, right? It is always, it's always looking to combine, and it's not stable.
Yes.
Anything which has lowered its energy is stable. Exactly, that's very, very important. Point number one. So by releasing a lot of lattice energy, sodium chloride becomes very, very stable. Number
Right.
one. Number two is that it also means that if you have to break that lattice, if you have to break that bond, right? You have to supply energy equal to that lattice energy in order to break it.
Yes.
So if the lattice energy is high, then you'll have to supply more energy to break the bond. Hence, stronger will be that bond.
Yes.
Is that clear? So these are the three factors which are going to favor an ionic bond formation. Ionic bond is usually ionic bond or electrovalent bond is usually the strongest of all bonds. You might have heard of covalent bond, you might have heard of coordinate bond, metallic bond, Van der Waals forces, hydrogen bonding. Among all the different kinds of bonds, ionic bond or electrovalent bond is the strongest. Is it clear so far?
Yes.
Any doubts in this?
No, sir.
Okay. We can also talk in terms of electronegativity difference. Okay. There is something called electronegativity, right? It refers to the tendency of an atom to pull the electron cloud towards itself in a bond. All right. So usually an ionic bond is formed between two atoms having an electronegativity difference of greater than 1.7. So there are some numbers assigned. For example, electronegativity of fluorine is 4, electronegativity of chlorine is 3, that of sodium is 0.9, like that. All right.
Yes.
Electronegativity of hydrogen is 2.1, the phosphorus is 2.1. So there are some numbers assigned based on their ability to pull the electron cloud towards themselves. That means they are craving for electrons.
Yes.
All right. So higher the electronegativity difference, between the two participating atoms,
Right.
greater will be the strength of the bond, and the ionic bond is favored when electronegativity difference. If you want to add it as a separate point, that also can be done. Or it's, of course, it's kind of indirectly redundant because any bond that is formed between low ionization energy and high electron affinity atoms will be having high electronegativity difference.
Yes.
Let me just write it here as a separate point. Electronegativity difference. So let me call it as delta E for the time being, okay? Electronegativity difference. If this electronegativity difference is between 0 and 0.4, then the bond is said to be non-polar covalent. It is covalent and it is also non-polar. We'll talk about it, okay? Next, we'll be speaking about covalent bond. There I'll talk about non-polar and polar. If delta E value is, let's say, between 0.5 and 1.7, then we call it as polar covalent bond. This bond is called polar covalent bond. And if the electronegativity difference is greater than 0.7, usually 1.7, you can call it as an ionic bond. Greater than or equal to 1.8, I can say. Greater the electronegativity difference, greater is the strength of the ionic bond. Okay, so what is electronegativity? Electronegativity is the tendency of an atom to pull the electron cloud towards itself. We'll talk about it when we talk about covalent bond next. So any doubts in this so far?
No, sir.
Okay. So let's move on to some discussion on covalent bond. Some basic discussion on. Okay. So contrary to electrovalent bond, where complete electron transfer happens from one atom to another, right?
Yes, sir.
Sodium loses an electron, chlorine gains an electron, correct?
Yes, sir.
In a covalent bond, what is going to happen is nobody loses the electron, nobody gains the electron. The electrons are shared, okay? So covalent bond is a bond formed by supposedly equal sharing of electrons. Among the participating atoms. Or species, okay? The bond formed by equal sharing of electrons, okay? All right. Usually, see here, if you observe electrovalent bond, it is a bond usually formed between a metal and a non-metal. Sodium is a metal, chlorine is not.
Right.
Usually, covalent bond is formed between two non-metals. Okay. For example, hydrogen combining with another hydrogen atom, chlorine combining with another chlorine atom, oxygen combining with another oxygen atom, nitrogen combining with another nitrogen atom. So these are all examples for covalent bond. Let's take an example. So as we discussed earlier, covalent bond is of two types. One is non-polar covalent bond. So what is a non-polar covalent bond? there is no polarity developed in the molecule. Polarity means what? Positive, negative charges. No polarity is developed in the molecule. What is the reason for that? Very little electronegativity difference. Electronegativity difference is 0 to 0.4.
Right.
That means both the participating atoms are having almost equal tendency to pull the electron clouds.
Yes.
Not that one of them is stronger in pulling that electron cloud towards themselves, towards itself. Both of them have almost equal capability to pull the electron cloud towards themselves. Therefore, equal sharing of electrons happens. Okay.
Yes.
Let's take a couple of examples here. Let's take example of chlorine. Formation of chlorine molecule, right? Cl2, right? So you already know, right? What is the electronic configuration of chlorine?
1s2.
In the first orbit, 8 in the second orbit,
and
7 in the
third orbit.
third orbit, right? So let me just draw it here. So this is chlorine nucleus. I am skipping writing the protons, okay? So first orbit, you know, contains
Two electrons.
2 electrons. What about second orbit?
8 electrons.
Yeah, there are 8 electrons. Third orbit has
7 electrons.
7 electrons, right? All right.
Yes.
Okay. Now, what happens is it will be very happy to accept an electron and become, satisfy its octet structure. So octet means what? Having 8 electrons in the outermost orbit. That structure is referred to as what?
Octet.
Octet structure. All right. Now, that was possible in the previous case, right? Sodium was donating the electron, chlorine was accepting the electron, correct?
Yes, sir.
There is another thing which could happen where another chlorine atom, right, comes closer to this.
Okay.
And what happens? So that also has, in its first orbit, 2 electrons, second orbit, 8 electrons, and third orbit, 7 electrons, correct? Yes, Samuel?
Yes, sir.
Yeah. Clear, Samuel?
Yes, sir.
And there are 8 electrons in the second orbit that I am just redrawing it for you. And there are 2 electrons in the first orbit. That's clear, right?
That's good.
Now, what will happen is these two chlorine atoms will come together, come closer. And what would they do?
They would share the electron.
Share the electron, right? 1 electron of chlorine will be shared here. Is that clear? So this chlorine atom will contribute 1 electron. This chlorine atom will contribute 1 electron. They both will form something called as a covalent bond. Is that clear?
Yes.
So now these 2 electrons which are kept in the middle, one contributed from each of them, is shared by both of them. That means the ownership both the atoms are going to enjoy. All right.
Yes, sir.
So these 2 electrons belong to both the atoms after the bonding process.
Yes.
So this is the other chlorine atom. So now tell me how many electrons are there in the chlorine atom on the left, outermost orbit?
6 are there.
No, not 6. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. How many electrons are there in outermost orbit of the chlorine atom on the right?
Also 8 electrons.
8 electrons. So both of them have their octet structure satisfied. That's how
They form an octet.
bond, a single bond is formed between chlorine and chlorine.
So it's single covalent bond.
Single covalent bond is formed. It is non-polar because there is no polarity developed because both of them attract this bonded pair of electrons equal.
Yes.
How many protons are there in this chlorine atom? On the left?
17.
17 protons. How many protons on the right?
17 protons.
Yeah, so they both attract those bonded pair of electrons equally with equal strength.
Yes, sir.
Okay, good. So this is the explanation of formation of single bonded covalent bond. Now let us look at the formation of oxygen molecule. Any doubts in the previous one?
No, sir. That's good.
Okay. What is the atomic number of oxygen?
8.
8. What is the mass number?
16.
16, correct. What is the number of protons?
Also 16.
You know, atomic number is equal to, what is the definition of atomic number? Atomic number is equal to the number of protons is equal to the number of electrons, right? So what is the atomic number?
8.
So number of protons will be
8.
Number of electrons will be
8.
8. And how many neutrons are there?
Protons is 8. Number of electrons is 8. Neutrons is 8.
Here, what is the mass number of oxygen? 16. So number of neutrons is also 8. Because number of protons is 8, number of neutrons is 8, 8 plus 8, 16.
Right.
Is it clear?
Yes.
Now we'll talk about oxygen molecule formation, right? So I'm just skipping writing the protons of oxygen. Let me simply represent it by O. So one oxygen atom is there. This is the nucleus. Then I'm drawing the first orbit. How many electrons are there in the first orbit?
2.
2. All right. Second orbit, how many electrons are there?
There have to be only 6.
6, very good. 1, 2, 3, 4, 6. All right. How many more electrons does this oxygen atom require?
2.
2 more. Very good. Right. So what happens is there is another oxygen which comes in contact, in its vicinity, right? This is the nucleus, let's say. First orbit. How many electrons will be there?
2.
2 electrons will be there. What about the second orbit? How many electrons are going to be there?
6.
6 electrons are going to be there. Got it?
Yes.
So now what is going to happen is these 2 oxygen atoms are going to come closer and they are going to keep 2 electrons each. In chlorine, we saw how many electrons each?
1.
1 electron each. Here in oxygen, they're going to keep 2 electrons each in the middle, which means, they're available for sharing. So totally how many electrons are available for sharing now?
8.
4 electrons are available for sharing.
Right.
These 4 electrons are kept in the middle are available for sharing. So how many electrons totally are there in the outermost orbit of the first oxygen atom, the left oxygen atom?
There's 8.
8. All right. These 2 electrons also. These 2 orbitals overlap. These 2 orbits overlap. So what happens is The 4 electrons are common for both the oxygen atoms.
Yes, sir.
What about this oxygen atom?
That also is 8. Okay.
8 electrons. So 2 electrons correspond to 1 bond.
Mhm.
So how many bonds are there between oxygen atoms?
Double bond.
Double bond is there. Is that clear? So oxygen,
Yes.
double bond O. So that's why it's O2. All right.
Yes, sir.
Previous one was Cl2.
See.
So this is O2. Is it clear to you?
Yes.
Any doubts?
No, sir.
Okay.
So is there any polarity developed?
No polarity developed. So this is also a non-polar. Why? See here. How many protons are there, Samuel? On the left side,
8.
oxygen atom, 8 protons. How many protons here?
Also 8 protons.
Yeah, though, so they equally pull the electron cloud. So there is no electronegativity difference. Therefore, there is no polarity.
Okay.
Polarity shall be developed only when they have unequal capabilities of pulling the electron cloud.
Yes, sir.
Okay, we'll see the such example. So is this clear to you?
Thanks.
Okay, now we'll move on to one more molecule formation of nitrogen. That is also a non-polar. You can be rest assured, right? If a bond is formed between 2 identical atoms, certainly it will be non-polar.
Hmm.
Nitrogen, what is the atomic number?
7.
7. Mass number?
14.
14. So how many protons, how many electrons, how many neutrons?
7 protons, 7 electrons, and 7 neutrons.
Correct. So now if you see, let's say, let me just simply draw N. So nitrogen nucleus, this is. First orbit of nitrogen has how many electrons?
2.
2 electrons. Second orbit of nitrogen, how many electrons?
5.
5. All right.
Yes.
Let me draw the nucleus of the other nitrogen atom. First orbit of that nitrogen has how many electrons?
2.
2 electrons. And the second orbit of that nitrogen atom has how many electrons?
5.
5 electrons. All right. Now, let me sample. So each of them, each of the nitrogen atoms, as you can see, they keep 3 electrons each for sharing. So totally, how many electrons are there for sharing?
3. So 6.
6 electrons. 3 pairs of electrons are there for sharing. So what's going to happen is, this leads to formation of 3 bonds.
Triple bond.
Triple bond. Now tell me, how many electrons does this nitrogen have in its outermost orbit?
8.
8 electrons. How many electrons does this nitrogen have?
8.
Yeah, so that's how their octet structure is satisfied. The electronic configuration is satisfied. So it is N triple bond N.
Triple covalent bond.
Yeah. And of course, all bonds which are formed between identical atoms is going to be non-polar in nature.
Done, sir.
Done? All right. Okay, so you understand about covalent bond right now, correct?
Yes.
It arises out of equal sharing of electrons. Obviously, if you compare the strength of this bond versus the strength of ionic bond is
More.
stronger than that of covalent bond, right?
Yes.
Now let's look at the bond formation between two atoms which are non-metals. But then that bond is going to become polar covalent bond.
Right.
So what do you mean by polar? There are going to be charges developed in the molecule. Not complete charges as in case of sodium chloride. Okay, partial charges are going to be developed. So let's take an example of hydrogen chloride, HCl molecule. Formation of HCl molecule. What is the atomic number of hydrogen?
1.
1. So let's say this is a nucleus. And surrounding the nucleus, you have how many electrons? First orbit.
Only 1.
1 electron, clear?
Yes.
Okay. Now, let's talk about chlorine molecule. Chlorine atom. Of course, the nucleus. First orbit, how many electrons?
2.
2 electrons, right? Second orbit, how many electrons?
8.
8 electrons are going to be there. And what about the third orbit?
7 electrons.
Very good. Now we come to the third orbit. 7 electrons are going to be there. Got it, Samuel?
Yes, sir.
Now, each atom provides 1 electron. So that how many electrons are there for sharing now totally?
2.
2 electrons. Therefore, a bond is formed. Covalent bond is formed. So hydrogen has how many electrons, Sam?
2.
2 electrons. This corresponds to stability for hydrogen because it attains the nearest inert gas configuration, helium. What is the atomic number of helium?
2.
1s2. Okay. Or in the first orbit, there are 2 electrons. Okay.
Okay.
So hydrogen attains that configuration. It's called duplet structure.
Duplex.
Duplet.
Oh, duplex.
Hydrogen attains duplet structure. Having 8 electrons in the outermost orbit. This is called octet structure. Octa refers to 8.
Yes.
Duplet refers to 2 electrons. Is it clear, Samuel?
Yes.
So what is the nature of the bond formed? It is covalent bond. However, now can you tell me how many protons are there in hydrogen?
There's only 1.
1 proton. How many protons are there in chlorine?
70.
73. So who is more effective in pulling this bonded pair of electrons?
Chlorine.
Chlorine, because electrons are negatively charged. Protons are going to pull that electron cloud, right? Nucleus is going to pull the electron cloud. So if you see, 17 protons are more effective in pulling the electron cloud towards itself than 1 proton. Are you clear?
Yes, sir. So electricity is more in that case.
Of course, electronegativity of chlorine is much more, right? It's 3 versus that of hydrogen is 2.1. So electronegativity difference is 0.9. So if the electronegativity difference is more than 0.4 and then less than 1.7, it forms a polar covalent bond. So what happens as a result? As a result, this bond, which is supposed to be equally shared, is kind of more oriented towards chlorine.
Right.
There is, you say, a chlorine nucleus pulls the electron cloud towards itself.
Right.
All right. Because of that, it's almost like chlorine is taking away those electrons and hydrogen is losing those electrons.
Right.
But it's not that, the bond is broken. It is not that the electron is transferred completely. Therefore, it is not complete charge. So what happens is partial charge appears, delta minus. Why delta minus? Because it's almost like electron is going to be added to the chlorine, right?
Right.
It's almost like electron is removed from the hydrogen. Therefore, it gets a positive charge. Not complete positive charge, partial positive charge. So the development of charges is called polarity. Hence, it is a polar covalent bond. Is it clear?
Yes.
Any doubts in what we have discussed? Fundamentals?
No, sir.
Okay. So if you note it down, then we can just move and revisit in detail. Okay.
Done, sir.
Okay. Fine. Okay. Now we get into. Have you heard about S orbital, p orbital, p subshell, d subshell, and f subshell?
Yes.
Okay. So when you write the electronic configuration, we wrote a very simple way of writing it, right? 288 in case of argon, or 287 in case of chlorine, right?
Yes, sir.
But ideally, we will follow something called Aufbau principle, which you have learned in your periodic property. Am I right, Samuel?
Yes, sir.
So what does that say? It says the way in which electron gets filled is, according to a particular rule, right? For example, even 2 I need not write. 2p. All right. So how does electron filling happen? First 1s orbital electron will fill, then 2s electron, then 2p, and then 3s, then 3p, and before going to 3d, it will go to 4s.
Okay.
Then 3d filling will happen, then 4p, 5s, then 4d, 5p, 6s, and so on. So this is the way electron filling will happen in this order. All right.
Yes.
You usually will say, what does this mean? This number 1, 2, 3, all that means orbit. First orbit, second orbit, third orbit, fourth orbit, right?
Yes.
So usually we'll expect, third orbit to be completely filled before going to the fourth orbit, correct?
Yes, sir.
But not necessary. That's not what happens. So there are, in the third orbit, if you see, there are 3 orbitals. So it's like inside a house, there are 4 rooms, right?
Right.
So just visualize like that. So in a particular orbit, there are orbitals, right? Or subshells here. Okay. So S subshell, P subshell, D subshell, and F subshell. S subshell can have a maximum of 2 electrons. P subshell can have a maximum of 6 electrons. D subshell can have a maximum of 10 electrons. And F subshell can have a maximum of 14 electrons. Okay.
Yes, sir.
Fine. So we'll discuss, right? What kind of overlap. So if you have S orbitals, they have a linear overlap.
Right.
P orbitals, they can have a linear overlap or lateral overlap. Okay, we'll talk about it. So fine, let's just move on. So there are 2 types of bonds. One is called sigma bond, another is what?
Pi bond.
Pi bond, right? So in covalent bonding itself, if you see, there are 2 types of bonds, which is one is sigma bond, another is
Pi bond.
If bonding happens because of linear overlapping, which is stronger, okay, so then that's going to create a sigma bond. All right.
Right.
Lateral overlapping, right? So because of overlapping of two orbitals laterally, not linearly but laterally, then that is going to result in a bond formation called as pi
Pi.
bond. And pi bond is weaker compared to that of sigma bond. Is that clear?
Yes.
All right. Okay, now we'll skip some basic definitions and all that. Okay. So if you see, only noble gases exist independently. All right. Okay. And they are stable. Now, when I talk about molecule, what happens? Atoms combine to form molecules, right?
Yes.
Right. This is ethane, this is water, correct?
So could you go back to that atoms like please?
This one or this one?
The definition then.
Yeah.
Yeah. Thank you, sir.
Any questions, ma'am?
Oh no, sir. Just wanted to.
Okay. I'll share this presentation also after our class. Okay.
Okay, sir.
So what's a bond? Chemical bond, if you see, the force of attraction which holds various constituents like atoms, molecules, etc. together in different chemical species is called a chemical bond. So why does an atom combine to form a molecule? To attain what we call as stability. So how does an atom obtain stability? By decreasing the energy content of the system. I told you, right? Whenever energy is released and energy is low, then the system is stable. A high energy system is always vibrating, always in intention to combine, correct?
Correct.
Yes. So, but very important. So, how does it attain this? By attaining what? Octet electronic configuration in most cases, except in case of elements like hydrogen, which don't crave for octet. They just crave for what? Duplet structure.
Right.
So all atoms combine to form molecules, of course, except noble gases. Noble gases are what? Inert gases. Helium, neon, argon, krypton, xenon, radon. They chemically combine with any other element nor among themselves due to stable electronic configuration. They have octet configuration already in their electronic configuration. Therefore, they don't have the need for combining. Is that clear? They're
Yes, sir.
already stable by themselves.
Right.
Okay. So whenever a bond is formed, energy is released. Okay. For example, energy is released when a bond is formed between two hydrogen atoms. So the resulting hydrogen molecule, right, H2, is more stable than the hydrogen atoms because hydrogen atoms have higher energy. After they combine, they release energy and become stable.
Right.
Right. So energy released is 43.5 kilojoules. Okay. Now this process is called what? Nuclear fusion.
Right.
That's responsible for a large amount of heat generated and light generated in stars. Smaller nuclei like hydrogen, helium combine together and release humongous amount of energy, right?
Yes.
Matter is made up of same or different types of elements, right? Is the basic unit of matter, atom. Now this, can you answer? How an atom combines to form a molecule? Yes, Samuel?
Yes.
See, a molecule is more stable or atom is more stable?
Molecule.
Molecule, right? So how does an atom attain stability in terms of energy? Which is having more energy, atom or molecule?
Molecule.
No. Atoms are in high vibration state. They are having more energy. They will release energy and combine and form molecule.
They decrease energy.
Yeah, by decreasing the energy. Is that clear, no?
Right.
Because once the energy of the system is low, then it's more stable.
Right.
So which of the following does not form molecule?
Noble gases.
Right. Okay. So why noble gases are inert in nature? Their outermost shell has 2 electrons or 8 electrons. Except helium, if you see, all the other noble gases, if you see, what is the number of electrons in the outermost orbit?
8.
Yes. Therefore, that corresponds to stability. So they don't have a need to combine with other elements. Okay. Why molecules are more stable than individual atoms? Because they possess less energy. So how do atoms combine? Atoms combine together in order to complete their respective octet, right?
Yes.
So some questions, all these are answered by bonding, right? Why do certain atoms combine while certain others do not combine? Why do atoms possess only certain combinations? Why do molecules possess different shapes? All these can be answered in chemical bonding, right? There are many theories which are there. Okay. So number of outermost electrons in noble gases is what?
8.
Or 2. Because helium, if you see, it's what?
Helium is a noble gas.
So what is the right answer?
2.
2 or 8.
2 or 8.
During the formation of chemical bond, what happens to the energy?
It decreases.
Decreases. Right. Okay. So there are different approaches which are there. VSEPR theory,
Right.
valence bond theory, molecular orbital theory, right? All these. So a couple of them are observation based, a couple of them are quantum approach based.
Yes.
Okay. So what are the different types of bonds? Ionic bond, covalent bond, metallic bond. Covalent bond can be further divided into what?
Polar and non-polar.
Polar and non-polar, right? Okay. And don't worry about the names or stuff.
Okay.
So what is octet rule? Atoms can combine either by transfer of valence electrons from one atom to another or by sharing of valence electrons in order to achieve 8 electrons in the valence shell, and this is called octet rule. Clear, Sam?
Yes.
So an atom can satisfy its octet configuration by either transfer of electron, which happens in electrovalent bond or ionic bond, or by sharing of electrons, as it happens in covalent bond. Clear?
Yes.
Okay, this we have already seen. So chlorine atoms combine, so they keep 1 electron each for bonding, so that those 2 electrons are shared by both the chlorine atoms. Clear?
Yes.
So these 2 electrons which are in the middle are shared by both the chlorine atoms. Clear?
Yes.
So in this case, it's 288 for both of them. Got it? What is 288? Outermost orbit of each of them has 8 electrons.
Right.
Whereas in sodium, what happens? No? You already seen. 11 electrons are there. Here, how many electrons are there? 17 are there. What is going to happen? 1 electron comes from here to chlorine. So
Right.
the configuration becomes 2, 8 here. Here it becomes 2, 8, 8. Are you
Right.
understanding, Samuel?
Yes.
This electron which was here is going to be shifting to the chlorine atom.
Right.
Did you see that?
I did, sir.
So what happens? Chlorine's configuration becomes 288 and sodium's become 28. So outermost orbit becomes the second orbit, not the third orbit. Therefore, it attains stability. So it becomes sodium plus and Cl minus. Clear?
Yes, sir.
All right. So octet means having?
8 electron.
Yes, in the outermost orbit. Okay, some symbols are there. The formation of molecule, only the outer shell electrons are going to take part in the chemical combination. They are known as valence electrons. So what are valence electrons? See here. Chlorine had how many electrons, Samuel? In the outermost orbit?
Outermost it had 7.
That is called valence electrons. So that shell, outermost shell is called valence shell.
Oh.
So how many electrons were there in chlorine? In the valence? 7. So valence electrons is 7. How many electrons did sodium have in the outermost shell?
That had only 1.
Yeah. So the valence electrons in case of sodium is what? 1. Clear?
Yes,
So
sir.
valence shell means what?
Number of electrons present in outermost shell.
That is valence electrons. What is meant by valence shell? The outermost shell is called
Valence shell.
valence shell.
Right.
The inner shell electrons are well protected. These are not generally involved in bond formation. So as far as bond is getting formed, we have always seen, that is happening due to the electrons in the outermost orbit, right?
Right.
So only the valence shells are involved, or the valence electrons are involved in bond formation. Clear?
Yes, sir.
So you write something called Lewis dot structure. That's very simple. See here, hydrogen has how many electrons totally?
1.
1. So you represent with 1 dot. Helium has how many electrons? 2 electrons totally. You represent with 2 dots. Lithium has 3 electrons. First orbit has how many electrons, Samuel?
1.
No, first orbit. Lithium has 3 electrons,
2.
right? 2. Outermost orbit?
1.
1. So you just write the electrons in the outermost orbit. So only 1 dot. Sodium, come to sodium. Sodium has how many electrons totally?
It has 11.
11. But if you see, the first orbit has 2, second orbit has 8.
Third orbit has 1.
You just mentioned that outermost orbit electron. That's it. 1.
Yes.
So like that for all atoms, right? Chlorine totally has how many electrons?
7.
17, right?
17.
But you don't represent all the 17. The first orbit 2 and the second orbit 8.
Only third orbit.
Only the third orbit, only the outermost orbit. How many electrons are there? 7. So you mark 7 dots.
Yes, sir.
Is it clear to you?
Yes, sir.
It's called Lewis dot structure. So the number of dots around a symbol represent the number of valence electrons, not electrons, total electrons. Number of what?
Dots around symbol represent number of valence electrons.
What do you mean by valence electrons?
Number of electrons present in outermost shell.
That's all. Clear?
Done, sir.
Okay. Good. Come on, tell me.
Only outer shell electrons.
Only outer shell electrons are involved. Right. Good. In case of chlorine,
7.
dots will be
7.
7 because that represents the number of valence electrons. Good. Okay, we'll just see one example of Lewis dot structure. Carbon monoxide molecule. How many electrons are there in valence electrons are there in carbon monoxide sample? Carbon, what is the atomic number?
6.
Yeah, 6 means first orbit 2 electrons, second orbit
4.
4, right? So how many valence electrons are there in carbon?
4.
4, good. Oxygen, can you tell me? What is the atomic number?
8.
So number of valence electrons?
6.
6, very good. So total number of valence electrons, 4 in carbon, 6 in oxygen. So what is the total?
10.
10, right? That's step 1. Is it clear to you?
Yes.
Yeah, if you want, you can make a note.
Done, sir.
Okay. What is step 2? So put a single bond between carbon and oxygen. One shared pair of electrons between carbon and oxygen. See, always when you put a single bond, it refers to how many shared pair of electrons?
1 shared pair.
1. If you put a double bond?
2 shared pair.
Correct. Okay. Now, if one bond, if you draw between carbon and oxygen, so out of the 10 electrons, 2 electrons are consumed, correct?
So we have 8 remaining.
Remaining 8 electrons are going to be there on the oxygen as 3 lone pairs.
Right.
So that completes octet and 1 lone pair on carbon we have.
Right.
Okay. So do you see this now?
I do so.
So these two atoms, these two electrons which are there, right? They form a bond. So the remaining 3 pairs are available as lone pairs, and 1 lone pair is available with carbon. Clear?
Yes, sir.
Any doubts on this?
No, sir.
Okay. See here, in this structure, octet of carbon is not complete, right?
Correct, sir.
Do you agree? How many atoms, how many electrons are around carbon?
4.
4. Oxygen 8. Do you agree?
Yes, sir.
As in the structure, octet of carbon is not complete. Multiple bond is required between carbon and oxygen, correct? So our assumption that single bond was there is wrong.
Yes.
So what we should do now? Triple bond is required between carbon and oxygen. Therefore, we should shift the 2 lone pairs on oxygen as shared between carbon and oxygen so that octet of both remain complete. Do you understand, Samuel?
Yes, sir.
So now what happens? 3 electrons each are being shared. So now what happens? Carbon, around carbon, how many electrons are there?
8.
8. Around oxygen?
8.
8. So both their octets are correct. Therefore, this is the correct Lewis structure for carbon monoxide. So basically, you can write it as C triple bond O. Clear, Samuel?
Yes, sir.
Is it clear to you?
Yes.
Did you understand these 2 dots?
I did, sir.
3 bonds refer to 6 electrons. Totally 10 electrons are there. So 6 plus 2, 8. 8 plus 2, 10.
Yes.
So other examples, I will just forward this to you. You can prepare. We'll
Yes.
see for the time being, in interest of time. So you can clearly see, hydrogen molecule, there is a single bond. In carbon tetrachloride, if you see, surrounding carbon, there are 4 chlorine molecules. Each carbon gives 1 electron, chlorine gives 1 electron. So octet of both is satisfied.
Right.
Nitrogen molecule already we had seen.
Yes.
Okay. Okay, these you can do it as practice. You can see there are some cases where octet rule is violated. For example, in BeCl2, if you see, chlorine is happy because it has how many electrons?
That is 8.
8 electrons. Whereas beryllium, if you see, it has only what? 4 electrons.
Right.
Correct. So in this case, it is kind of under octet, right? I mean, the number of electrons for beryllium must be 8, but then it has only what?
Only 4.
4. Okay. Now in PCl5, what happens is, you can see chlorine is happy, right? Because it has what? How many electrons?
That is
8 electrons. But phosphorus, if you see, it doesn't have 8 electrons. It has rather 10 electrons. 5 bonds are there, right?
Yes.
Each bond 2 electrons. So over octet, super octet, you can say, right?
Right. The expanded octet.
Expanded octet, you can call, right? Carbonate ion, it has octet structure. Fine. These are again, Lewis dot symbol and predicting the valency. See here. Valency, how do you predict? Very simple. How many outermost electrons are here, Samuel? Nitrogen? 5.
5, yeah.
Octet minus 5. That gives you the valency. So nitrogen's valency is 3.
Yes.
Valency is called the combining capacity. So how many atoms can a particular element combine with? Right? It's all determined by
Valency.
valency. So valency need not be the same as the number of electrons which are there. Fluorine has 7 electrons in its outermost orbit. Valency is what?
The combining capacity.
8 minus 7, 1.
Hmm.
It just needs to take one more electron, isn't it?
Yes.
So its valency is 1. Neon valency is 0 because 8 minus 8.
That is an octet.
Yes. This already we had seen. What is the number of valence electrons in carbon monoxide?
10.
Correct. Number of lone pairs we had seen, right? After the bond formation. How many lone pairs were there on carbon and oxygen? Triple bond was formed, right? So wasn't it 1 1? See here, you just see the example here. So how many lone pairs are there, Samuel?
2.
1 pair for carbon, 1 pair for oxygen. Do you see this?
Yes.
So 1, 1.
Right.
Okay, valence of nitrogen atom, what is it? 3, because nitrogen's outermost electrons are 5. Valence is nothing but octet, 8 minus 5. So 3. Clear?
Yes.
This is also we had seen. Which of the following violate octet rule? Definitely BCA, BeCl2, we know that, we have seen.
Yes.
Suboctet. PCl5 expanded octet, right?
Yes.
BF3 also suboctet because boron trifluoride, if you see, boron has how many electrons? 3 electrons in its outermost orbit.
Okay.
Fluorine has how many? 7 electrons.
Okay.
It's 1 electron for sharing. So fluorine is happy because you know what is happening here?
That has 8 electrons.
8 electrons. But if you see boron, 1 pair, 2 pairs, 3 pair. How many electrons are there?
That has
6 electrons in its outermost orbit. Do you
right.
understand?
Yes.
So BF3 is electron deficient or electron rich?
Electron deficient.
Do you remember? We have learned that any compound which is electron deficient is called Lewis acid. It will be an electrophile.
Right.
Anything that is electron deficient will have craving for electrons, will have love for electrons. Clear?
Yes.
Okay, now we'll look at covalent bond formation. So what is covalent bond? Bond formed by equal contribution, mutual sharing of electrons. So most of your organic compounds are all covalent, like ethane, methane, propane, butane, butene, acetylene, all that. Then compounds which are formed between identical atoms, chlorine, nitrogen, N2, Cl2, O2, H2, all these are what?
Covalent bond.
Covalent. Even water, right?
Yes.
Is covalent. So why do they combine? In order to complete their electronic configurations. Clear?
Yes.
Okay. This we are already seen. So hydrogen bond is formed by because of sharing of 2 electrons. Chlorine is formed again by sharing of 2 electrons. So single bond between chlorine atoms. Yeah, both chlorine atom attain argon configuration. They get 18 electrons in the outermost orbit. Metals are not usually involved in covalent bond formation. It's bond between non-metals. And as we had discussed, single bond, double bond, triple bond. So when one electron pair is shared, it forms single bond. When 2 electron pairs are shared, it is double bond. So example, if you see water, methane, ammonia, etc., chlorine, all that. Only 1 bond. When 2 atoms share 2 pairs of electrons, like oxygen, ethene, propene, all these. Even carbon dioxide, if you see, double bond is there. This is ethene or ethylene. There is a double bond between 2 carbon atoms. Triple bond. We saw an example. What was that, Samuel?
Nitrogen.
Nitrogen. Very good. Another example, can you tell me from your organic chemistry?
Ethine.
Ethyne, very good. Acetylene. Very good. Triple bond again, right? Clear? When 3 electron pairs are shared. Which among the following has double covalent bond?
Oxygen.
Very good. So a covalent bond is formed between metals, non-metals, metals and non-metals. None of these.
Metals.
Sorry? Tell me, Sam. A covalent bond is formed between atoms of non-metals. What is Cl and Cl? Non-metal, right?
Right.
A metal and non-metal will happen in ionic bond. So what is the answer for this?
B.
B. In a single bond, how many electrons are shared?
1.
One pair of electrons are shared. What about a double bond?
Double means 4 electrons.
4 electrons or or 2
Or
electrons.
2 electrons.
Or triple bond means 3 electron pairs or 6 electrons.
Yes.
So which of the following is correct?
The first option.
Not the first option. A single bond is not formed by 1 electron.
Wait. 2. Single means just 2 electrons.
2 electron means 1 electron pair, correct? Where do you see pairs?
In V, C, and D.
Yeah, 1 electron pair corresponds to 2 electrons. That is single bond, correct? 1 electron pair, where do you see?
Option C.
That's all, right? 2 electron pairs are there means double bond.
Right.
That means 4 electrons. 3 electron. Are you listening intensely?
Listening.
Right. 3 electron pairs means how many electrons?
6.
6. Clear? So what is the right answer?
C.
So which type of bond is formed in nitrogen molecule?
Triple bond.
Yes. Okay, limitations of octet rule already we have seen, right? Not all. In some compounds, number of electrons surrounding the central atom is less than 8 or more than 8. You can see this example, PCl3, beryllium hydride, lithium chloride, all these, they don't have octet. AlCl3, BF3, in these also, the central atom does not have 8 electrons. Odd electron molecules, like oxygen has 8 electrons, nitrogen has 7 electrons. So total is 15, right?
Yes.
Similar. So in these molecules, if you see, octet rule will not be satisfied for all the atoms.
That's correct.
So do you see? In this case, nitrogen, it is not satisfied. Nitrogen has only 7 electrons. Oxygen has 8 electrons because 4 electrons are there. Double bond means 4 electrons are there. 4 plus 4, 8. Nitrogen has 3 electrons plus another double bond means 3 plus 4, 7.
Right.
So expanded octet or exceeded octet. So what is happening here? Not only NS, NP electrons are going to be forming bonds, but N-1 d orbitals also are going to form the bond. For example, if 4th orbit is the outermost orbit, then 4s electron, 4p electron will form bond, but also 3d electron can also form a bond.
Right.
Okay, the previous orbit, d orbital electrons can also participate in bonding. This can result in exceeded octet. For example, in we just saw PCl5, right?
Yes.
So yeah, PCl5, SF6, IF7, all these if you see, 10 electrons are surrounding the phosphorus atom. Therefore, it is expanded or exceeded octet. SF6 is also similar. 12 electrons surround sulfur atom.
Right.
Okay. Here also, if you see 1, 2, 3, 4, 5, 6, 6 bonds in sulfuric acid, right? H2SO4. So if you,
Yes.
so this also has expanded octet. Okay, there's something called formal charge. You just note down the formula right now. What will be the charge on the molecule, or what is the charge on the atom? You know, we will see. Please note down the formula. Formal charge is equal to total number of valence electrons in the free atom minus total number of non-bonding electrons, or in other words, number of electrons in the lone pair. Minus half the total number of bond pair electrons, which means minus number of bonds. This gives you formal charge.
Done.
Repeat, formal charge is nothing but total number of valence electrons minus number of lone pair electrons minus half the number of bond pair electrons, or you can simply say, you can remove that half and say number of bonds. Okay.
Yes.
We'll just see if calculate for one of them. Okay.
Ozone.
Okay. Now let's look at ozone. In ozone, if you see it's O3, right? This is the lowest structure, is already given to you. So for each of the 3 carbon and oxygen atoms, you need to find out what is the charge on them. So let's
Then
take the first oxygen atom. Calculate, Sam. So what does it say? Number of valence electrons. So how many valence electrons are there in oxygen?
4.
Atomic number is 8, right? So how many will be the valence electrons?
6.
Okay. So that's why first 6, then minus number of lone pair electrons. How many lone pair of electrons are there, Samuel?
4.
Dots represent, yeah, 4. So minus 4. Did you get it? And how many bonds are there, Samuel?
Double bonds. It's a double bond.
Double bond means 4 electrons. So minus half into 4.
Right.
Or in other words, you can simply say, how many bonds are there?
It's a
2
double.
points. So I can subtract 2 from this. Or
Minus
half into 4, whatever. So what do you get totally? You get 0. Therefore, there is no formal charge on the first oxygen atom.
Yes.
Is it clear?
Yes.
Okay. Now next. Can you calculate the formal charge on the second oxygen atom, Samuel, with the same formula?
One.
Okay. How did you calculate? So number of valence is 6, right?
Yes.
Then how many lone pair of
Lone pair
electrons?
is 2.
2. So 6 minus 2, 4. How many bonds are surrounding this?
Just a single bond.
No. Here now. Here there is one bond. Here how many bonds are there?
2.
So 1 plus 2 is what? 3, right?
3.
So 4 minus 3, 1.
Yes.
Plus 1. Clear, Samuel?
Yes.
So the formal charge on the second oxygen atom given is plus 1. Can you calculate the formal charge on the third carbon atom?
Minus 1.
Minus 1. Why?
Because number of valence electrons is 6. Number of lone pair electrons is also 6.
Bond pair.
Lone pair, sir.
Lone pair is also 6. 6 minus 6, 0. Minus?
Half into 2.
Half into 2 you can write, or you can simply say one bond is there, right? Minus 1.
Yes, sir.
Clear, no?
Yes.
So that's how you arrive at the formal charge for a particular compound. Okay, good. Fine. Again, other examples, you can check it out yourself. Okay, I'll send this to you. Okay. Number of valence electrons in phosphorus in PF5 is PF5 or PCl5, already we have seen phosphorus has exceeded octet configuration, right? 5 bonds are surrounding phosphorus atoms. So how many electrons are there?
10.
10. Yeah. Around sulfur, how many are there?
12.
So 4. Huh?
12.
12, right. 6 bonds are there. So 12.
How they
So
asking?
you just have to, we have already, you'll see it in the example, 0.
Oh.
Okay, but now we'll quickly go through ionic bond. So what is ionic bond? Bond formed by complete transfer of one or more electrons from one atom to another atom is called electrovalent bond. I have given you the example of sodium chloride, right?
Yes.
You can take example of magnesium chloride. In this, 2 electrons will be transferred from magnesium to chlorine.
Right.
One each will go to one chlorine atom.
Right.
So MgCl2, that is also an ionic bond.
Yes.
So sodium fluoride, sodium chloride, calcium chloride, magnesium oxide, all these are ionic bonds. Basically, if you see the first group of elements and the second group of elements, the combination that they have with non-metals will give you an ionic bond.
Yes.
For example, sodium has 11 electrons, so fluorine has sodium outermost orbit 1 electron is there, that will be transferred to fluorine. Clear?
Yes.
Sodium loses its one outermost electron, fluorine gains 1 electron to attain stable octet configuration.
Right.
This already we have seen. So sodium outermost orbit has 1 electron. Chlorine outermost orbit has how many electrons?
1.
Chlorine outermost orbit.
Oh, chlorine. 7.
7, right? So it is craving for 1 electron. Sodium is willing to give this 1 electron. So sodium transfers 1 electron completely to chlorine. So sodium becomes sodium plus, chlorine becomes chlorine minus.
Yes.
CaCl2, calcium is interested in giving 2 electrons away because in its outermost orbit there are 2 electrons. By losing them, it attains the octet structure of argon. So it becomes Ca2 plus and each Cl becomes Cl minus.
Yes.
Yes, I know. So ionic bond will depend on formation of what? Positive and negative ions from the neutral atoms. So a metal losing an electron to give you M plus, and the energy that you supply is called ionization energy or ionization enthalpy. All right.
Right.
And a non-metal accepts an electron to become an anion. This energy is called electron affinity or electron gain enthalpy. Both are same names, electron affinity or electron gain enthalpy. Ionization energy is same as ionization enthalpy. Electron affinity is same as electron gain enthalpy. Electron gain enthalpy is the amount of energy released when an electron is added to a neutral atom.
Yes.
Ionization energy is the energy supplied to remove the electron.
Yes.
Okay. Okay. Formation of ionic bonds are favored between usually group 1 and group 2. Group 1 alkali metal, group 2 alkaline earth metal. Like sodium, potassium, rubidium, cesium, right? Those
Yes.
are group 1 metals. Group 2 metals are what? Calcium, magnesium, barium, all that, right? Usually they have what? Low ionization energy. What do you mean by low ionization energy? Little energy is required to pull the electron out of their orbit. Got it?
Yes.
And non-metals of group 16 and 17. 17 are all halogens, right?
Yes.
Fluorine, chlorine, bromine, iodine. 16 has what?
16 is halogens.
Sorry, 17 has halogens. All right.
16
16
is
actually
sulfur.
oxygen, nitrogen,
Sulfur.
oxygen, etc. Right?
Right.
Okay. So electron gain process may be exothermic or endothermic. Ionization energy is definitely endothermic. So in ionization energy, you are going to supply energy to pull the electron out.
Yes.
Electron gain enthalpy in case of non-metals, if you see like chlorine, they are happy to receive that electron. Therefore, energy will be released. It will be exothermic. But there are cases in which if you supply energy, electron can be added. For example, in in let's say in metals, they don't want to accept the electron, but you are forcibly pushing the electron into it. Then the electron gain enthalpy will be endothermic process. That means you have to supply energy for that. Got it?
Yes, sir.
Ionic bonds will be formed more easily between elements with low ionization energy and high electron gain enthalpy. Clear?
Yes, sir.
Why negative value? Because it is usually exothermic reaction.
Yes, sir.
We have already learned in thermodynamics, right? Endothermic reactions will have positive enthalpy.
Yes, sir.
Delta H will be positive. In case of exothermic reactions, delta H will be negative, right?
Yes.
Which are going to favor ionic bonds? Elements with low ionization enthalpy. Example, group 1, group 2 elements like sodium, potassium, group 1, or barium, calcium, magnesium, correct? Group 2.
Yes, sir.
With group 16 like oxygen or group 17 like chlorine. Got it?
Yes.
High negative value of electron gain enthalpy. Then we talk about electronegativity difference. I told you, right? So usually electronegativity difference is high between the two participating atoms. Then is when you have ionic bond formation. Typically, I told you a number greater than 1.7 electronegativity difference. That helps in ionic bond formation. For example, sodium is having very low electronegativity. It doesn't have any tendency to pull the electron cloud towards itself, whereas chlorine has a very high value for electronegativity.
Yes,
so it
sir.
has a tendency to pull the electron towards itself. The electronegativity difference between the atoms forming the bonds must also be quite high. Properties of ionic bonds. They exist in solid state. Ions are arranged in a crystal pattern, right? Regular pattern. They obviously have high melting and boiling points. They are soluble in what? Polar solvents, right? The sodium chloride is soluble in water, not
Right.
so much in petrol, right?
Correct.
The petrol is non-polar solvent, whereas your water is polar solvent, right?
Yes, sir.
Polar compounds or ionic compounds will be soluble in polar solvents. That is why
Right.
in most of the ionic reactions, water is used
Right.
and not benzene. Benzene is also solvent, but you don't use it in ionic reactions. Why? Ionic compounds don't dissolve in non-polar solvents. All right. Usually, ionic compounds are good conductors of heat and electricity in their solution, aqueous solution state or molten state. So, sodium chloride as a solid, right? It will not conduct electricity.
Yes, sir.
You can't pass electricity through your common salt.
Right.
But if you add common salt to water, then it becomes aqueous solution that conducts electricity.
Yes.
Okay. Or if you provide enough temperature to common salt and it melts, in the molten state, it will conduct. All right.
Yes, sir.
And ionic reactions are very, very fast compared to covalent reactions. Why sodium chloride is a bad conductor of electricity in the solid state? See, for conducting electricity, you need mobile ions.
Oh, what's this one?
For conducting electricity, you need mobile ions, ions which are moving, right?
Right.
In solid state, it is in the form of crystal. Ions are not moving.
Yeah. Because it doesn't have enough ions.
Enough ions are there, but they are not free to move. They are in crystal structure, lattice structure. Clear?
Yes. Yes, sir. So could you show that question again? Yeah. So the answers.
In solid state, sodium and chlorine ions are not free to move. If you melt them, then the bonds are broken, then they can move easily. Similarly, in aqueous state also, they are freely available as sodium plus ion, and it's no longer a crystal, right?
Yes, sir.
Here, your common salt is a crystal, right?
It is.
So in that state, it won't conduct. But if you dissolve it in water, the crystal structure is gone, right?
Yes, sir.
Okay, silver nitrate gives a white precipitated sodium chloride solution, but not with CCl4. CCl4 is non-polar, sodium chloride is polar. Sodium chloride is an ionic compound due to ionization in polar solvent like water, chlorine ions and still. So NaCl dissociates to give sodium plus and Cl minus. The Cl minus combines with Ag plus ions of silver nitrate to form Cl, silver chloride. But such a reaction is not possible in carbon tetrachloride because it is non-polar.
Yes.
Okay, sir.
It is a polar.
Tell me, Samuel, what is the right answer?
Ions occupy fixed positions.
Perfect.
Water is a non-polar solvent. No. Water is a high volume liquid which has no taste and no. So what is solvation, sir?
Solvation is the process of making it soluble. So it's obviously going to be the fourth option. Water decreases the intra-ionic attraction in the crystal lattice due to solvation. They get soluble in water.
Yes.
Tell me. Consider X is metal, Y is non-metal. X is sodium, Y is chlorine, like that. What can you say about the ionization energy? What can you say about the electron affinity? We have already discussed. Yes, no?
Low ionization energy and high electronegativity.
Yes, low ionization energy for sure. The other one should be high electron affinity or electronegativity. Does not matter.
Yes.
Third option is correct. Good. So what can you say about the bond formed between cesium and chlorine?
Ionic.
Bond. Dative bond means coordinate bond. I will explain that later. So what is ionic bond? Bond due to complete transfer of electrons. Cesium belongs to group 1 and chlorine belongs to group 17, right?
Yes.
And kind of bond formed between group 1 and group 17 is always ionic.
Right.
So I was talking about lattice energy in crystals. So what is lattice energy? Energy released when required number of positive and negative gaseous ions combine to form 1 mole of the compound. So when they form crystal lattice, the energy is released. They become very stable.
Yes.
Okay, so ionic compounds in crystalline state consist of orderly 3D arrangements of cations and anions held together by Coulombic forces. Coulombic means electrostatic forces.
Right.
I hope there is a diagram given. Let's see. These compounds crystallize in different crystal structures, different depending on the size of the ions, size of the charge on the ions, and their packing arrangement. So this comes under a topic called solid state, which was there in the second year earlier. Now in the revised syllabus, it has been removed. Okay.
Yes.
What kind of packing is going to be there in crystal lattice and all that, that is removed. So no problem. So in ionic solids, some interesting point. The sum of electron gain enthalpy and ionization energy may be positive, but still the crystal structure gets stabilized due to the energy release in the formation of crystal lattice. See here.
Yes.
Samuel, overall, when atoms combine to form molecules, what do you expect the energy profile?
When atoms combine to form molecules.
Yeah. What should happen to the energies? Compare the energy of atoms and molecules.
Atoms energy is high, molecules energy is low.
So lower the energy, tell about stability.
The more the stability.
Very good, Sam. So what is happening is, see, you want energy to be released or energy to be absorbed in bond formation?
Released.
Released, very good. When it's released, then it's a stable bond, right? So if you see in ionic solids, the sum of electron gain enthalpy and ionization energy may be positive, which means ionization energy is always endothermic, right?
Yes.
That means your supply energy, it's a positive energy. You're increasing the energy of the system by providing energy. Now,
Right.
Electron gain enthalpy, I told you it can be either endothermic or exothermic.
Yes.
In most cases, it is exothermic. So it's negative delta H, correct?
Yes.
So when you add the two, that means a positive delta H and negative delta H, you're going to add. The resulting answer will be positive if plus delta H is more.
Right.
Resulting answer will be negative if the minus delta H is more. Or in other words, electron gain enthalpy is more negative.
Yes.
Now what happens is, there may be a situation where if you add both of them, you get a positive number.
Yes.
If you get a positive number, the problem is what? It shows as though it is an endothermic reaction.
Right.
What is the problem with endothermic reaction? If it's an endothermic reaction, then
Absorbs.
it's absorbed, right?
Yeah.
So molecules will have more energy than atoms. Then they won't be more stable than atoms, correct?
Yes.
So, but there is a third component which comes in, which is what? The energy released in the formation of crystal lattice. Got it?
Got it.
So it is not just two atoms coming together, but they are forming crystal lattice. During the formation of crystal lattice, a lot of energy is released. So that energy also, if you add overall value, electron affinity, or electron gain enthalpy, ionization energy, and lattice energy, if you add all the three, you get a negative answer. That's good. That means energy is going to be released.
Yes.
So that's what has been told in this particular statement. Good structure is given. So this is how a sodium chloride structure is formed. You see orderly arrangement.
Rock salt.
So if you see all these bigger anions, these are bigger anions, right? Chlorine has 18 electrons, correct?
Yes.
17 plus 1 gained. Whereas sodium only has 10 electrons, correct? Total.
Because one lost.
One lost. And smaller size.
Yes.
And this is coming from Coulomb's law. You will learn in 12th.
Which law, sir?
Sorry, no?
Which law, sir, you said?
Coulomb's law. This is called Coulomb's law. Coulomb's law of electrostatic attraction.
Right.
Electrostatic attraction. Okay. So this attraction keeps the bonds together.
Right.
So it is directly proportional to the product of charges, inversely proportional to the distance between them.
Yes.
So it is K Q1 Q2 by R square. Just note it down. Later you can learn in detail in 12. So if you see ionization energy for sodium plus, sodium is 501 kilojoule. That means you have to supply 501 kilojoule per mole of sodium chloride so that sodium becomes sodium plus. Got it?
Yes.
Electron gain enthalpy of chlorine. That means when you add an electron to chlorine, energy is released. How much is released?
Negative.
Minus
48.
But if you add these two, right, the
Hmm.
overall energy is positive still.
Yeah.
It is still not favoring formation of the bond.
Yes.
Because for formation of the bond, the overall sum of the energy must be what? Negative.
Negative.
That means it's exothermic, correct?
Yes.
So that is where lattice energy comes into picture. So when the lattice is formed, huge amount of energy is released. So when you add all the three, overall value is definitely negative, right?
Yes.
Therefore, bond formation is highly favored. So qualitative measure of the stability of ionic compound is not only considered based on octet, right?
Right.
You should also take into account the enthalpy of lattice formation.
Yes.
Okay. So lattice enthalpy can also be defined as the energy required to break the bond. Completely separate 1 mole of solid compound into gaseous constituent ions. So greater this energy, stronger will be the bond.
Yes.
So lattice enthalpy you can define in two ways, as I told you earlier in today's class. First way is the amount of energy released when the lattice is formed.
Yes.
Or in other words, the amount of energy that you have to supply in order to break the bond.
Right.
Higher this energy, stronger is the bond. Is it clear? That means you have to provide 788 kilojoules of energy per mole of sodium chloride in order to convert 1 mole of solid sodium chloride into 1 mole of gaseous constituent ions and separate them to infinite distance.
Yes.
Okay. This makes sodium chloride very, very strong.
Right.
Okay, among the following, which deviates from octet rule?
BF3.
Very good. We already saw that. Excellent. Number of valence electrons in carbon, carbonate ion. Carbon, how many valence electrons are there?
4.
Oxygen,
6.
how many atoms are there? 3 atoms, right?
Yeah. 3.
3 into 6
18.
plus another 4.
22.
But then 2 minus means how many electrons have been gained?
2 electrons. So 24.
24. Clear?
Yes.
In formation of ionic bond, which of the following is true?
Shared between metal and non-metal.
Sharing happens only in covalent bond sample. Ionic bond means electrovalent bond. Sodium transfers 1 electron completely to chlorine, right?
So transferred from metal to non.
Yes or no?
Yes.
Okay. Now, what kind of bonding will you expect, or what kind of? Yeah, come on. Element X is strongly electropositive. Element Y is strongly electronegative. Both are univalent. So the compound formed by them will be what?
X plus Y minus.
That's all.
So
Strongly
what is univalent?
is like sodium. Strongly electronegative is like chlorine. So they form Na plus and Cl minus. Correct?
Yes. So what is univalent, sir?
Univalent means valency is 1. For example, oxygen is bivalent, right? It is valency is 2. Nitrogen is trivalent. Its valency is 3. Aluminum is trivalent, 3. Sodium monovalent. Chlorine monovalent. Fluorine monovalent. Got it?
Yes.
Monovalent means what?
2.
Monovalent or univalent?
1.
1. Bivalent or divalent?
2.
Trivalent, 3.
3.
Tetravalent.
4.
Carbon is tetravalent.
So that has 4.
Yes. Okay. X plus Y minus is correct. Okay. The charge on a cation is +2. Anion is -3. What should be the formula of the compound? Can you tell me? I've already given you the answer. Fine. So you know crisscross, right? You must have learned.
Crisscross method, yeah.
That's all.
Hmm.
M2 A3. So when you crisscross, what do you get? Or in other words, here
M3A2.
I'll tell you here. Suppose let's take a typical example, calcium. And here -3, I can say phosphine. Phosphine. All right. 3 minus 2 plus. All right.
Yes.
If you see, calcium is willing to provide how many electrons?
2.
And phosphorus is willing to take how many electrons?
3.
So, how many calcium atoms are required?
3.
3 calcium atoms, I'll get 6 electrons. That will be taken by 2 phosphorus atoms.
Okay.
So 6 electrons requirement is there, and calcium 2 plus 3 of them provide 6 electrons. Clear?
Yes.
So M3 A2. Is that clear to you?
Yes.
Or you could also do it by crisscross, correct?
Yes. That's it.
Valency is 2, non-metal valency is 3. So when you do this, M3A2. Got it, Samuel?
Yes.
Okay, ma'am. So polarity of bonds, we had just briefly discussed about it. So when covalent bond is formed between 2 similar atoms, for example, hydrogen, oxygen, chlorine, nitrogen, fluorine, their pair of electrons are equally attracted by the 2 identical nuclei. Such type of bonds are called what?
Non-polar covalent bonds.
Non-polar covalent bonds. Polarity. In case of heteronuclear molecule like HF or HCl, right? the shared electron pair between two atoms gets displaced towards more electronegative atom. For example, we just saw, right, HCl.
Right.
Hydrogen, what was the number of protons? What were the number of protons? 1.
1.
Chlorine had 17 protons to attract the electron cloud. So 17 protons attracting the one pair of electron is much greater impact than
Hydrogen.
1 proton attracting the 2 electrons, right?
Yes.
So there is a displacement of the electron towards the chlorine.
Yes.
So the displacement of electrons towards the more electronegative component is going to be the source for polarity in the compound.
Yes.
That doesn't happen in identical atoms, correct?
Yes.
So as a result of polarization, the molecule possesses something called dipole moment, right? So we can discuss that probably in the evening class today. So dipole moment you will learn in physics again in 12th in more detail. If I have, what is a dipole? Equal and opposite charges. Small equal and opposite charges separated by a small distance. This forms a dipole. If the charge is Q, then the dipole moment represented by P will be equal to Q into D. You can just make a note of this formula later. Anyways, in physics, chemistry, you need to know it. Physics, you will learn it in much deeper way in 12th.
Done, sir.
Okay. So H delta plus, Cl delta minus. Could you explain this? What is happening here, Samuel? We'll probably conclude with this. So why is there a delta minus on chlorine and delta plus on hydrogen? Could you explain? And what is this bond called?
So it's a single covalent bond.
Single covalent bond. But then what is it? Is it polar or non-polar?
Non-polar.
See, non-polar means no polarity, no positive negative charge. Here there is polarity, correct?
Polar covalent bond.
Polar covalent bond. Polar covalent bond will only exist between hetero atoms, which means what? Atoms belonging to different elements. Why?
Right.
Why?
So plus delta represents the positive part of hydrogen as it is giving 1 electron to
It
chlorine.
doesn't give one electron. They have covalent bond means what? They are supposed to equally share.
Okay.
But what happens? Didn't I tell you? Chlorine has 17 protons. It attracts the bonded pair of electrons more vigorously towards itself.
So it is negative.
So it is not completely minus charge, it's partial negative charge. Because it's almost like, electrons are moving towards chlorine.
So even for plus delta, it's a partial positive charge.
Partial positive charge only, right? Both are equal in magnitude, opposite in sign.
Right.
And dipole moment is the product of charge and distance between the two. So dipole moment mu is equal to E into D. E is the charge, D is the distance.
Yes.
And dipole moment is used expressed in D by units, or you can also say Coulomb meter. Coulomb meter is SI unit. You can note down the conversion. One is in SI, another one is in CGS.
Done, sir.
Okay. And dipole moment is a vector quantity. So you will apply what vectors concept you have used in physics here as well. We will see that in the next class.
Yes, sir.
Okay, so this we will see. The polyatomic molecule, we'll see it in the next class. Okay, Samuel, any doubts in today's class?
No, sir.